Okay, so we're heading back to our iReady packet. And so we're going to be working on page 136 and 137, finding equivalent expressions. So we've been working on quite a few textbook pages that were all leading us up to this, okay? You need to know how to do each of those things. And so we practiced them, so now we can kind of combine them and find it all together. Okay, so it says, Miss Lim asked her class to find an expression equivalent to 7 minus 3 times 4 minus 2x minus 10x. So we want an equivalent expression to this, okay? And remember, equivalent is another word for equal, okay? So one step in each of the following students' work is incorrect. Find and explain the error. Then write your own expression equivalent to the one given above. Okay. So let's look at John. Okay, so John wrote the problem. So let's rewrite the problem ourselves. Okay, so take a look. It looks like John combined these two things to give us that 4. Okay, but remember, in our order of operations, please excuse my dear Aunt Sally, okay, where we have parentheses, exponents, multiplication, division, adding, and subtracting, okay? They subtracted, but subtraction's way over here. This right here represents multiplication. So multiplication should come first with the parentheses, okay? The only ones that we can move around, these two can be moved around, and these two can be moved around. But subtraction and multiplication cannot be moved around. So we should have multiplied this out first, okay? So that's where John went wrong. He subtracted first. Not okay. Let's look at Madison. Madison, if it looks like all right, so something went here to give us this. So it looks like maybe she subtracted also, but she subtracted the 4 and the 2x, and we can't do that. So she was dealing with her parentheses, so that was okay. But what she did, so she subtracted inside the parentheses, okay? However, they are not like terms. So that's not okay. That's not okay. Okay? Let's look at Selena. So Selena, okay, it looks like she multiplied. She did that correctly and got 12. But uh-oh, she forgot to distribute that 3 to the negative 2. So she forgot to distribute the negative 3 to the 2x. Okay? All right, so John didn't follow the order of operations. Explain what he did wrong. So remember, John was the one who subtracted right at the beginning. Okay? So he subtracted 7 take away 3. instead of distributing the -3 first. Okay? Madison made a mistake when combining like terms. Explain what Madison did wrong. So remember here, she combined the 4 and the -2. They were not like terms, so she was not allowed to do that. Okay, so she subtracted 4 minus -2, but they are not like terms, so that's not allowed. Okay. Selena used the distributive property, but she didn't do it correctly. So where did she go wrong? So remember, she multiplied the 3 times 4, but she forgot to multiply that -3 times the -2. Okay. She multiplied the -3 by the 4, but forgot to multiply the -3 by the -2x. All right, so it says write an expression that is equivalent and show your work. All right, so according to our rules of operation, we should distribute first. So remember, this is what you need to deal with first. Okay? So we're going to distribute here. So -3 times 4 and -3 times -2x. You have to remember to distribute both numbers. So what do we get? We get -12 and we get a positive 6x. Why? Because a negative times a negative is a positive, and 3 times 2x is 6x. Okay. Now, we have not touched those other two numbers. So they need to just come straight down into our problem. Okay. All right, now what? Now we need to combine like terms. So look, 6x, oops, and -10x. Those are like terms because they both have an x. Okay? So use a t-chart if you need to. 6x is positive, 10x is negative. They're on opposite sides, so that does tell us to subtract. And because 10 is bigger, it will be negative. So you get a -4x. Okay? These are also like terms because they are constants without a variable. So again, use a t-chart, +7, -12, opposite side, so that tells us to subtract. And because 12 is bigger, it is negative. So we get a -5. Okay? So 7 minus 3 times 4 minus 2x minus 10x is equivalent to -5 minus 4x. And you could have written that the other way, -4x minus 5. It doesn't matter. Either way. Okay? So these are equivalent. How can you be sure you use the properties of operations correctly to form an expression that is equivalent to the original one. Okay, well, work it out. Okay, so we worked it out and combined like terms. Okay, you have to use your order of operations, your please excuse my dear Aunt Sally, and then combine like terms. Okay. Use what you just learned about equivalent expressions and solve these problems. Okay, so it says, is this equivalent to this? Why or why not? Well, let's try it. So first thing we got to do, get rid of these parentheses by distributing. So this problem right here needs to be distributed. So -2 times 3 and -2 times 2n. All right, so we get -6 minus 4n. All right, bring down the rest of this problem. Now we're ready to combine like terms. So let's start with our variables. Use a T-chart if you need it. Opposite sides tell us to subtract. 7 is bigger, so we get a positive 3n. Use a T-chart with our constants. They're both negative on the negative side, so we get -14. Is that the answer they wanted from us? No. So no, -8 minus 2 times 3 plus 2n plus 7n is not equivalent to -30 minus 13n, right? This is what it's equivalent to, okay? All right, let's look at the next one. Wants to know, is this equivalent to this? All right, so the first thing you probably should do is change those fractions into decimals to make it a little easier to deal with. All right, so 1/4, which is a quarter, so that becomes -0.25y plus 2 1/4 y plus 2 minus y. All right, so we don't have parentheses, so we don't need to distribute anything, but we do have a lot of like terms. So I have a y, I have a y, and I have a y. Okay, so let's use our T-chart. So -0.25, positive 2.25y, and -1y. Okay, so remember when they're on the same side, that tells us to add. So we have 1.25y. And then when they're on opposite sides, we subtract. So 2.25 minus 1.25 leaves us with 1. So we get 1y plus 2, because of course I didn't use that 2, right? So is it equivalent? Yes. Okay, this right here is the same as this, right? Because there's always that invisible 1 in front. So -1/4 y plus 2 1/4 y plus 2 minus y is equivalent to y plus 2. Okay. If you're not understanding, please come on to WebEx the next time I'm on and ask before you take your quiz. I want you to do your best and get your questions answered. All right, good luck.